Okay, so I'm going to give you some tips on RDM. I will tell you a few tales about things that I've come across in my time. Obviously, these are all completely anonymized. Names have been omitted to protect the guilty, and in some cases, the irredeemably silly. But hopefully, it will at least point you in a useful direction as we go along. First off, so going to let me do that? There we go. The first question is, what's the point of doing all this? Well, I probably don't need to tell you guys this. I'm sure you're all pretty much on board with all this, but there are two basic goals for a good research data management. The first one is obviously to make your research data fair, findable, accessible, interoperable, reusable. You guys don't know all about this, so I don't need to repeat that. But the other really important reason is to make your life easier. And it genuinely does, I promise you. If you actually look after your data properly, if you manage it, you'll be able to find it, you'll be able to access it properly, you'll be able to share it with others. You just will make your entire life so much easier. There is nothing worse than coming to the end of a study and having to hunt around for the data that you needed to write up. And research data management will prevent that from happening. I promise. I absolutely promise. I mean, it's also it's just generally good for your own work processes. So how do we actually do that? How do we make your life easier? Well, the first thing we do is we have to know why we're doing what we're doing. That's foundational. And obviously, again, you guys all know all about this, integrity and transparency. These are our guiding principles. You are all already well and truly on board with this, but it's important to keep in mind that we want to make sure that things like verifiability, reproducibility, and reuse, these are the kind of core ideas at the heart of what we're doing when we're managing the data. We want this built into our decision-making processes from the very beginning. So we want to be thinking in terms of verifiability, reproducibility, and reuse right from the start and all the way through. Because, you know, we all saw what happened during the pandemic, COVID research being released, misinformation about COVID research, genuine research being questioned and misquoted, and in some cases, alleged research being made up. People doing their own, my favorite phrase, doing their own research. You know, there are a lot of people out there in the world who are, to use a technical term, cocoa bananas, and the only way to get past that is to present good, solid research and to be clear and open about it, to be transparent, to show our working. That's the only way we're going to really gain and keep public trust in academic research. So the second thing, which is still part of the first thing, is to know what you're doing and why you're doing it. You have to know what the expectations and what the requirements are. It's important you know that what your institutional policies are. Here at the University of Edinburgh, we do have a research data management policy. The link is in the slide notes. I'll share these afterwards, obviously. So please do make sure you go and check that out and make sure that you know what you're expected to do. It also has information about how you find help to do things you need to do, so it's well worth looking at. But it's important to know about your funder policies as well. Most of the funders have fairly straightforward policies nowadays involving data management, planning, data preservation, and data sharing. Same with the publishers. It's so important that you know what these are before you get started. I actually was just speaking in the last week or so to a researcher who was in the process of applying for funding, had just discovered, had done the sensible thing, had read their funder policy, but had just discovered that they would be expected to share their research data at the end of the project. Did not want to do that, and so came to us to ask, to my team to ask, well, how do I get the funding but not do what they want me to do, which is a condition of the funding? And we stared at them for a long time until they went away, because there's no sensible answer to that question. Publisher policies can be just as problematic. We've had cases, there was one case recently, researchers in education were on the verge of publishing a quite an important article in a major journal. They'd gone through the whole editing process, review and everything else, got to the point of publication, and the editor said, can I have the DOI so that we can make your data available? the researchers had to turn around and say, well, unfortunately, we can't do that because our sample is, our participant pool is too small, and it's not possible to anonymize the data properly. At which point, the editor, who was quite annoyed at this point, just threw up his hand and said, well, we're not publishing your journal article in that case. You know, this could have been avoided if they had just read the policies in the first place, the publisher guidance in the first place, and made sure they understand what was actually needed from them. Second tip, know what you're doing, know what you're doing it to. Okay, so what do we mean by data? It's important to keep in mind. We do use this slightly old-fashioned word data to talk about a lot of different things. You know, broadly speaking, the kind of general definition we want to use now is any materials that would be needed to support the findings or conclusions of a research study or a research publication. So anything you would need to validate your findings, anything that would be needed to replicate your study. So we're talking about data, yes, but we're also talking about code. We're talking about protocols and methodologies and any contextual information that might make it easier to understand the data, any information about analyses. I know the UK Data Service, I was at an event session the UK Data Service did just recently. So anyone working in social science type data, UK Data Service is really pushing for a lot more contextual information around the data, anything that's going to make it easier to understand the data that they are ingesting into their reshare repository. So do think beyond just spreadsheets. I know we always say this to people. It's easy to get stuck in this idea that we're just talking about spreadsheets, but we need to think about anything that would be needed to validate or replicate a study. Tip 3, really important, documentation. Write everything down. Don't forget to write anything down. Everything you write down is going to be useful in one way or another. When you are documenting your data, obviously you need to know, you need to have enough information so that you can find your data, access it, interpret it, and analyze it when you need it. So when you come to the end of your study, easiest way to do that is to think about what would another researcher need, what would a reviewer need, or an examiner need, what would a colleague need who had you know, a colleague for another research field who maybe didn't fully understand what you were doing. What would they need in order to be able to find your data, to access it? So will they have enough information about the software? Will they have enough information about what the naming conventions mean? Will they be able to interpret your data? Have you made, you know, have you documented your field codes and things like that? How have you analyzed your data? Have you written all that down? The more stuff you write down, the easier your life will be, because it means you don't have to remember all this when it comes to actually writing up your findings at the end. Tip 4, don't forget to deposit your data. I know it sounds stupid, but it used to be incredibly common. I'm certain it never ever happened at the University of Edinburgh, but I came up here from the University of Surrey a year or two back, and it used to be standard practice for researchers to come to us and say, can I have a DOI for my data? And we would say, yes, here is your DOI for your data, but please do come back and deposit your data. And they would say, yes, I will come back and deposit my data. And then we would never see them again. We would chase them, we would email them, and they would just ghost us completely. So I don't know that they were actually forgetting to deposit their data, but I'm being kind to them now. So please don't forget to deposit your data. Make sure you put it in a repository. Make sure you make it as open as possible. We all know that there is plenty of evidence for improved citations. There's a couple of papers referenced here. The link should be in the notes at the bottom. That there is a citation advantage attached to papers that share their data, but it's more than that. Okay, it's also about adding resources to the pot. It's about putting resources back into your own research community, your own community of peers, because this is how research progresses, how science progresses. It's how education progresses. People put their data, they put their research back into the common resources to be used by other people to develop their own projects and to learn from. You know, this is exactly why we no longer live in a Newtonian universe and don't have to be afraid of apples falling on us all the time. It's also very important that when you put your data in a depository, don't just share it, make sure you promote it. There is a standing myth in academia that good research will float to the top and be noticed. I promise you this, there is only one thing that floats to the top, and it's dead fish. Make sure that your papers, your outputs, your data, everything gets properly promoted. Use a DOI, get it in all your publications, use it in conference papers, in social media posts. Use a data access statement. You get a metadata record in the university's current research information system, PURE. Make sure you get it properly licensed, a CC BY license for preference. Make sure that you link all your outputs together using your ORCID numbers and everything else, because everybody's got one. I know you've all got an ORCID number because you're all good. You're all good people. There's an example here of one. We've got loads of these examples in DataShare actually, but this is just one example of a data sharing study. Professor Peter Sanderco, his international historic trials, this data has been used in a number of different studies over the years. It's been picked up again and again and again. It gets adapted, it gets amended and added to. The new data built on the original data gets put back into DataShare mostly, luckily. It then gets used for multiple publications. It's absolutely fantastic. You should go and have a look. If I'll send them, as I say, I'll send the slides around afterwards. And there's a whole YouTube series of video on this as well. It's well worth checking out if you have the time. So tip 5. Keep your data safe. Now, I'm not going to wang on about not using USB sticks and not using Google Drive and stuff. You all know that already. You all know that the only way to really be sure about to prevent loss and to prevent damage to your data, or prevent unauthorized access to your data, is to make sure it's on secure storage, preferably network storage. But if you really want to know what happens when you don't, you could consider, for example, back in early 2000, I think it was 2007, the UK government managed to lose personal data information about every single family in the UK which who had was getting child support. So they had a massive database of families receiving child support, which is virtually 100% families in the UK. It has massive take up. They downloaded all of this data onto a couple of CD-ROM disks. They put those disks in the post and they sent them off to another department, and they were never seen again. That is the personal details of almost every family in the country at the time. So you've got bank details, you've got individual names, addresses, you've got information about the children, and it just disappeared because they popped it in the post. They didn't put it anywhere sensible. There have been examples of universities losing data. One particularly famous example about 10 years ago of a research group at an unnameable university who lost a huge wodge of climate data when they were moving labs. They were just moving from one lab to another. The data hadn't been stored properly. No one knew what was happening, and a huge amount of data of climate change data was lost. And you can imagine the kind of scandal this creates. I mean, this got out into the newspapers, and all of a sudden every nut job out there is claiming it's clearly a fake, it's all false. You know, all these researchers, they're all in the pay of big meteorology, driving Ferraris and what have you. Absolute nightmare, all because they didn't look after their data properly. Or one of the worst ones that I've actually heard about or come across is a PhD student who was at UCL, who unfortunately happened to have all their data, I think physical sciences, I think he was doing, and he had all his data stored on his laptop. Unfortunately, his laptop was stolen. He put it in his gym bag. His gym bag was stolen. His laptop was gone. He'd lost all that data. He was not then in a position to recreate that data. He couldn't afford to do that. He didn't have the time. And so he was not able to complete his PhD. He actually had to, he was able to finish a master's degree, but that was as far as it goes. So it really stunted his educational career and his academic career going forward. It's not just for storage, though. Please keep in mind communication platforms where you're gathering your data, when you're collecting your data. It's really important to think about the platforms you're using. the university's data protection officer, Rena Gertz, has said that Teams is secure for conducting and recording interviews for research purposes. We still have so many people who just want to use Zoom, which is not secure, or WeChat, which is definitely not secure because the Chinese government has complete access to it. We've actually had cases here at the university where we've had mostly master's students using WeChat to do their interviews, their project interviews. And when I pointed out that this was not a very good idea and that it was a contravention of the university's data protection policy, I was told that, well, some of them had already done it and we couldn't disadvantage the others by preventing them doing it. Yes, it's a terrible idea to disadvantage students by preventing them from breaking the law. Absolutely. It's a mess, and it's going to get really messy. It's going to get worse as we go on because there are people who are insisting on using these things. People insisting on using Google Drive. There's loads of research projects using Google Drive to gather participant information. I actually spoke to a relatively senior researcher over in the law school just about 2 months ago. And when I suggested that they put their data on Datastore or OneDrive, I was told, and I'm not joking now, this is exactly what she said, I don't trust the university's network storage. I would rather keep my data on Dropbox. So we have no idea who has access to that data or where it's stored, but it's more trustworthy than the university's own network storage, which is run by a bunch of guys here in Edinburgh. Okay. It is difficult to know what to say to that, but, you know, deep breaths, moving on. Tip 6, this is the big one. This is the most important one. This is the most important thing you will ever do in your entire life. It's huge, it's vast, it's deeply significant. Planning, please make sure you draft a data management plan. Don't just do that. Plan your research properly from start to end as well. This here in front of you is a data lifecycle, a simplified data lifecycle, much simpler. If anyone's seen the DCC data lifecycle, that can give you a migraine. This is our nice easy one, which is meant to keep you sane. You can see there data management planning right at the center of this. There's a good reason for that. It's because data management planning is the most important part of the whole process. I promise you, I absolutely guarantee, stone cold, no time spent planning is time wasted, okay? Planning is the only way to make sure that you have control, consistency, accuracy in your project. It's the only way to guarantee that your data is going to be verifiable, that your findings are going to be verifiable, your studies are going to be reproducible. It's the only way you can anticipate problems, mitigate them. It ensures your data is findable when you need it to write up. Ultimately, without a plan, you don't actually have a project. You just have a random sequence of events, loosely connected, probably accidental, and definitely poorly thought through. This is your chance to think all of these issues through and get them right from the start. Don't pass it up. It will absolutely make your life easier in the long term. Also, it works. I was just contacted by a researcher about 2-3 weeks ago. I'd helped this researcher. They'd come to me originally in the beginning of the year. They were submitting for AHRC funding. They come to me to help with their data management plan. I did that. I'd like to think we did a pretty good job, actually. And she came back and told me that her funding had been awarded, the project was going ahead, and the data management plan was looking like it was going to really help things out. Now, I'm not saying the data management plan was the reason she got the funding, but it definitely didn't hurt, and it definitely set her up to do the project in a much more efficient, easy, and straightforward way going forward. Now, those are the main 6 tips. Couple of honorable mentions, really important. Make time for research data management. It's not an add-on, it's not an extra, it's an essential part, it's an integral part of your project. Start as you mean to go on, get everything documented, decide what your naming conventions are going to be, decide how you're going to organize your data, think carefully about what you'll do when the project ends and you need to either deposit your data, or if it's sensitive or personal, how you might go about disposing of it. Don't leave it till the end. Plan it from the beginning. Make sure that you implement your plan and update it as things go along. Things change, things always change. I promise you, as you go through your project, things will go wrong. If you've got a good plan, they won't go too wrong, but at least you'll be able to manage them, mitigate them. And most importantly, of course, when things do change, if things go wrong, if things change, make sure you update your plan, okay? And make sure you use it all the way through. Last thing, make sure you make your life easier. This is meant to be, this is designed to make things easy for you. So do take advantage of that. Last point, make sure you ask for help. You don't have to work all this stuff out yourself. You don't have to think about everything all by yourself. There are plenty of people here at the university. My team are always ready to help. Come to us if you've got any questions, because I promise you, you are not alone. But don't turn around, because we're watching you. We're watching you all the time. We're not really, they won't let us. They've made us get rid of the spyware. But do come and find us if you have any problems. This is my email address. This is my email address. This is our webpage. This is who we are. Come and find us if you have questions. Come and find us if anything's happening that you're not sure about. Always be happy to give you a hand. And that, ladies and gentlemen, is my presentation. So I will stop sharing. Whoops.
Thanks, Simon. That was a really, really helpful talk. Lots of good tips there. So before we all kind of run away to back up our hard drives, we've got Kaitlyn.
You don't need telling. You're not backing up on hard. Tell me you're not, please.
No, definitely not. So we've got Kaitlyn and Clara, who's going to tell us about their experiences. So we'll start with Kaitlyn first, if that's okay.
Sure. Thanks, Emma. I'll just try sharing my screen, hopefully with more success. Let's see. Okay. Is that working as expected?
Yes.
Yeah, good. Okay, great. So yes, I'm just going to talk a little bit about my experiences managing data, which might, I'm aware, be quite different to the sort of data that other people are dealing with. So I'll introduce that a little bit first. So I'm Kaitlyn Hair. I'm a postdoctoral researcher at within the CAMARADES group at the university. We're based in the Centre for Clinical Brain Sciences, and CAMARADES stands for Collaborative Approach to Meta-analysis and Review of Animal Data from Experimental Studies, which is quite a mouthful. But essentially, we are interested in trying to improve the validity and the translation of research conducted in animal and cell models to the human condition. So we want to improve that translation, and we want to make that research as good as it can be. And to do that, we're interested in conducting meta research, so research on research. So we could use systematic reviews and meta-analyses to kind of look across the literature and make sense of it and see what sort of things are being reported in studies and what things aren't being reported. We're also interested in developing automation tools to help us synthesize all of this evidence that's out there. And in the last few years, I've been really involved in creating what we call systematic online living evidence summaries, which is another mouthful, but we call these SOLS projects, and basically we sort of try and collect all of the research evidence in one area, and then we extract some information from the publications using lots of automated tools and machine learning and natural language processing, and then we display that on an interactive web application. So we're trying to make it easier for people to understand what's going on in their field, like within Alzheimer's disease as a whole, for example. So that's just to give you a bit of insight into where I'm coming from and the sort of work that I do, which might differ from a lot of you. So the sort of data I work with are things like citations and the associated data that comes in a citation. So things like, the title, the author, DOI, pages, volume, all that information that you have in a citation. And then attached to that are some identifiers. So maybe the identifier from PubMed, where you retrieve the citation, and other identifying information as well. I also deal with full text and because we're doing systematic reviews, we annotate those studies when they come through the pipeline. So I also deal with annotations that are linked to those publications. So things like what animal model was used in that paper and what was the drug that was used in that paper. And I'm also using numerical data that's linked to those publications as well, because we tend to extract information from the figures and, you know, the mean of this group and the mean of that group. So that's all the data that I'm dealing with. But today I'm going to mainly talk about the citation side of things. Especially this might be useful for people who are maybe thinking of doing a systematic review or some sort of project like that, where you're having to manage a lot of studies somewhere. So what I've found over time and through talking to people is when people start doing a systematic review, they sometimes look to things like Excel and Google Sheets. And I'm here to warn you against doing that because it's not a good idea. I've noticed that things like PubMed sometimes allow that as an export option, and I think it's a bit troubling in a way, because these are not designed for that purpose, and it's so easy to just delete something or for some formula to end up in a cell that you didn't expect it to. It's just not for that sort of work at all. It's maybe okay for some sort of early piloting or, you know, having a look at the data quickly at the start, looking at the studies you've got, but it's not good for the long term. And what people tend to advise is citation management software like EndNote or Zotero. And you might have used these already for writing papers or, you know, inserting references in Word. That tends to be what they're used for. It's easy to import citations from these databases fairly easy. It's easy to export from PubMed or, you know, the databases that we search for literature into EndNote. That's fairly simple, and it kind of formats everything for you. There's deduplication in there. So if the same record is in PubMed and it's somewhere else as well, and you're bringing both into the software, it can quite often identify this and remove those duplicates for you, but we know that it's not really optimal at doing this. It also has some functionality to retrieve full text, which is really useful, and to pull in additional metadata, although I have relied on this before. So there's an option to update your references to pull in, you know, if it's missing an abstract or something, it can sometimes pull it in. I've done that before without checking it, and it like really messed up a lot of my data. So I would not just trust that blindly. I wouldn't just let it update your entire library without checking it. Another thing I like is that it automatically generates an identifier for each citation, which is useful for future tracking back to that individual study. The problem is with the sort of data that I'm working with, you know, sometimes I have hundreds of thousands of references, and EndNote just cannot cope with that. It just dies instantly as soon as you try and put that many studies in it. So in the past, I used to have just so many files with backups and backups and backups of the same database, the same EndNote library, had to split it up into different libraries. It was just a disaster. So if you're dealing with a lot of citations, if you're doing some mega review or big project, I do not recommend it for that. It's also easy to remove papers accidentally, and it's not really designed for the whole systematic review process. I've spoken to people who've used it for things like screening or maybe adding annotations in the notes, and it's not really designed for that purpose. So I would definitely advise against using it for anything beyond that initial systematic search where you're bringing in lots of studies for a review. So in recent years, I've moved towards using R for basically all of my workflows and sort of data management. I'm aware that, you know, this option won't seem accessible to everyone. And if you're not, you know, a coder at the moment, or you don't know any R, it will be quite a big, steep uphill to get to this point. But I think it's worth considering, especially if you already know a bit of R and you're interested in doing this sort of thing. If you're interested in doing a systematic review or something that involves a lot of managing data. So there's actually lots of R packages out there to retrieve citations automatically from PubMed, lots of other databases as well, using application programming interfaces. It's not as difficult as it sounds, because if you've thought about it, there might be an R package out there already if you search on GitHub. But again, this This is anticipating a bit of literacy with R already, but there's packages to retrieve citations, import citations, deduplicate citations, reformat citations. The reformatting aspect is kind of up to you. There's a lot of flexibility in this approach, which might be good or bad, depending how you feel about that. There's also packages to pull in additional metadata, so things like DOIs if they're missing, or author information if it's missing. Also to pull in full texts as well. Because R is a script-based language, it should be reproducible. In most cases, you should be able to reproduce the same workflow. If you, for example, you're doing a systematic review update, you can put your citations through exactly the same process as before. In theory, anyway, it should be reproducible. Something that's kind of different is that a lot is up to you. If you use something like EndNote, it's generating things for you. It generates an identifier. Here you have to decide what your identifier would be, and I tend to use the accession numbers from PubMed or Embase or whatever database you retrieved the study from. I tend to use that because that should be unique. And because, as I mentioned at the start, our group are interested in applying AI tools and natural language processing tools on the studies, it makes sense to do it in a code-based workflow already. What I would say the problems are, again, there is an uphill battle in terms of having to learn this stuff, and it can be challenging to export citations from R. If you're a beginner or starting off in that journey, that is quite tricky. So I maybe wouldn't recommend it unless you have a bit of time to build up your skill set a bit. Managing data throughout a systematic review. Again, I've heard some stories of people trying to do this in Excel or trying to do it in EndNote, and I again would advise against that. It's just too many bad things have happened when I've had an Excel sheet open. And we tend to use systematic review platforms. There's many different options out there. We have an in-house one that we tend to use called Surf. And these platforms really allow you to be collaborative, they allow you to screen your studies for relevance and extract data, and it's all linked back to that publication. Ideally, you are maintaining a lot of that metadata that was in your EndNote library or in your R files that you generated. So what's really important and what has caused me problems in the past are things like whether those identifiers, like that record ID, actually goes into the platform and stays somewhere, so that when you export your data, you're not stuck thinking, oh, I've got all these annotations for studies and I don't know how to link it back to what the actual paper is. Another issue can be if they have their own deduplication software inbuilt, and whether if you put your citations in there, are some of them going to disappear and you don't know what's happened to them? Does it support things like attaching the full text? Does it support maintaining a lot of that metadata that you retrieved earlier, like DOIs and author information and all of that stuff? And what does it look like when you export the data? Basically, I would recommend having a look at all of these things, because when it comes to systematic reviews, we always have to produce what we call a Prisma diagram, which is basically like a flow chart saying, this is the number of studies we retrieved, this is how many we screened, this is how many we ended up with at the end. All of that information is so important, and you just can't keep track of it properly unless you've, planned at the start and thought through these things as you go through the process. I just wanted to touch briefly on going one step further. As I said, I'm managing a huge amount of data, so it's hundreds of thousands of citations. That won't be the case for everyone, but it might be that some people here are managing vast amounts of data and are struggling to do that using sort of more traditional approaches. So because we're also bringing in new citations frequently, so we're trying to refresh our SOLS platform every week, we have now switched towards using structured databases, so SQL databases. Amazon Web Services offers relational databases like this, and there's lots of other platforms that allow it. And using R, there's lots of ways to communicate with that database basically, and write things to the database, retrieve things from the database. I just wanted to mention it because I think databases seem quite scary to people who are not used to using them or creating them, and I've been pleasantly surprised actually that you can actually set up a database. It's not super complicated to build a simple one with a few different tables that are connected to each other. And if you are managing huge amounts of data, it has advantages in terms of backup and sort of data integrity and making sure everything maintains the structure that you want it to have. So yeah, finally, just want to say if you are doing like a systematic review or something like that, that you should seek out people with experience to help you in those early stages. As Simon mentioned, planning is the key to everything. Think about how you're going to get the studies, combine the studies, deduplicate the studies, how you're going to record, you know, what happens to them throughout the process and document each step. And if you are managing huge amounts of data, whether that's a systematic review or a completely different project, just don't be scared of things like databases, because maybe they might actually support you in what you're trying to do. Yeah, that was my last slide. Sorry, that was a little bit longer than I expected it to be, but hopefully it was useful.
That was a really great talk, Kaitlyn. Thank you. So do we want to finally move on to Clara now? Do you have slides or?
Yeah, can you hear me?
Yeah, I can hear you.
Okay, just gonna sort that out. Just gonna leave and then come back in again.
Okay, that's fine. If anyone has any kind of questions or any comments from the talk so far, feel free to put them in the chat as well. I'm not sure how much time we might have at the end for a discussion, unless people are willing to stay for a couple more minutes extra.
Okay, that took a bit longer than expected, sorry. Can you all see my slides?
Yeah, it's just popped up in the just the full PowerPoint. And that's a white screen.
Can you see that?
It's just a PowerPoint kind of app again.
Okay, I'll try maybe my screen. Can you see that?
Yeah, it's the app again, so I don't know if you need to go into the slides or
like, are you seeing the
yes.
slides?
Yes, we're seeing them now.
Great. Okay, perfect. Okay, I'll just get started. So yeah, good morning. My name is Clara, and today I'm going to talk a bit about my latest research, which was my master's dissertation here at the University of Edinburgh. So I wanted to start with a bit of my interests and what guided me to this project. So my interest for student mental health go quite early on. When I did my work placement in UCL as a research assistant, and besides my day-to-day responsibilities, I also had to do a dissertation where I focused on impacts, one of our projects. So I investigated the barriers that male students have to accessing mental health support. And then that led me to my psychology undergrad dissertation, where I focused on the effects of Brexit affecting EU students' mental health. So during my master's, recently I wanted to combine that students' mental health research with a new interest when I audited a course here at the university called Science of Close Relationships, which opened like a new world for me. So I wanted to do a bit of a mix. And that's what led me to investigate the effect of romantic relationships on student mental health. So I wanted to start with a bit of background and literature review on the topic. So I think we can all agree that student life is a very intense period. There's lots of new experiences, lots of changes, and lots of like new social interactions, which include close relationships and more specifically romantic ones, where in fact they have been seen to really impact both well-being and mental health. And this has been through more positive emotional bonding, a more positive concept of the self, and aiding in more integration with others. And this has led to results of less mental health issues. In fact, it is emotions that really help with this through giving a better knowledge, experience, and practice of this emotion regulation, and then these relationships, which inevitably affect one's own well-being positively. In fact, those emotion regulation strategies such as cognitive reappraisal and using less of negative ones such as expressive suppression is what's key in this positive mental health. Therefore, this is where my study came into place, where I investigated this on students, as most research focused on other age ranges or other types of relationships, but those in students was a bit lacking. And I also wanted to investigate this with more accurate measures, such as EMA, as this wasn't done before I investigated it. So my hypothesis was that I expected students who have a healthy romantic relationship, as I also saw that it's not only the fact of having a relationship, but if it is positive, that helps in mental health. Compared to those who are single, will have better mental health, especially lower levels of depression and anxiety, and that this would be mediated by better emotion regulation strategies. So my methods consisted of a 2x2 design, of a self-report between subjects of observational, and I managed to gather 259 participants, where 124 were single students and 135 were in a relationship. Their age range from 18 to 55, so quite a wide range, with the average being around 23 years old. The materials that I used was Qualtrics for the online questionnaire, and then Sigma 3, which is an app to measure the ecological momentary assessment. And in these, I included measures to measure depression, anxiety, and stress, and then the emotion regulation strategies, as well as interpersonal emotion regulation strategies. Finally, I also included a scale measuring relationship satisfaction to see those differences in like positive and negative relationships. And the procedure was quite simple, with participants completing this online questionnaire, and then they moved to app-based daily surveys for a week. The results were quite surprising. So I managed this in R, where I conducted structural equation modeling on the scores of the mental health scale and the emotion regulation strategies, as you can see in the SEM map above. Firstly, as expected, more cognitive reappraisal was related to significantly lower levels of the mental health issues, and then those who utilize more the negative aspect of expressive suppression had the opposite effect. However, when being reported through the EMA, as this the previous one was just seen in the online questionnaire, the cognitive reappraisal actually had the opposite effect for the mental health aspects of anxiety and stress. And interpersonal emotion regulation had no effect in the main questionnaire, but it did in the EMA, and it also negatively affected those mental health aspects. Then when it came to the romantic relationships part, they actually had a negative effect in anxiety, which was quite surprising. But when reported through EMA, romantic relationships were related to the positive aspect of perspective taken within interpersonal emotional regulation. And then finally, relationship satisfaction did not actually have any effect on either. So this indicated both positive and negative effects of emotional regulation, matching as well positive and negative mental health. But on the contrary, having a relationship actually affects anxiety negatively, and where relationship satisfaction does not have any effect. Therefore, what I concluded from these results was that my hypothesis was partially supported. So this fit previous research, but it also contradicted it. And here there's some things to consider. So first of all, my sample consisted of students which are known to have high mental health issues as a base. And as well, I saw that the relationship satisfaction were very high. So when these levels are very high as a base, it's more difficult to indicate where differences lie. And as well, it's important to mention that the image of romantic relationships has really shifted, especially in the recent years, where independence is valued more and commitment is delayed. And these results could also be due to some inevitably difficulties when navigating relationships, such as, for example, a higher chance of conflict that can lead to more stress, and that could have led to higher anxiety. These results could also be due to some limitations, for example, the sample size that was a bit more limited in the EMA. So this is a bit of an example that research is not always simple and works the way you want it to. For future research, I would recommend replicating this again with a bigger sample, especially for the EMA, to be able to get to more substantial conclusions. So this is a bit more of a preliminary study into this effect, but it was still conducted in the way that it had to, because EMA hadn't been used in this context. So the results were still valuable. And I would also maybe recommend doing a qualitative investigation, as relationships are a very complex topic, and qualitative lets the analysis of more in-depth results. Therefore, there were some things that went well and some challenges when managing this data. I'll start with the negative to end on a bit more of a positive side. First of all, I had a bit of a low sample size for EMA, which compared to what EMA studies generally are, it was still quite high, but it was a bit lower compared to, for example, the online questionnaire. This was due to some both questionnaire malfunctions. At the start, I was struggling a bit to get it to work for measuring the relationship satisfaction, so I had a bit of data missing from that. And then when it came to the app for the EMA, there was a bit of a malfunction with it not sending enough notifications. So that's why mainly the data was a bit lower. As well, this was due to the fact that this study was part of a bigger data collection. It actually started as an undergraduate project that I joined, so it wasn't focused since the start. However, there were some good points, such as I mentioned, a really high sample size, especially for the questionnaire. And this was thanks to starting data collection early, and because I managed to focus my data collection for some months during the summer as part of my master's part. So thank you all for listening. If you have any questions, I'll be happy to answer. And I also included the references.
Oh, thanks, Clara. That was really nice. That's, again, we're seeing as the theme kind of plan your data very early. Very overarching theme from the three presentations. Yeah, Crispin's got it right, hat trick of great talks. We only have 2 minutes left, until 11, so I don't really know if we have any questions unless anyone's got anything like a burning question. But otherwise, I'm going to say thank you to all of the speakers. And yes, Simon saying plan, plan, plan. That is our advice to everyone.
Definitely. It will save you so much time.
Yeah. So that everyone's kind of going already, but I'll say goodbye to everyone left. Very nice to see you all.
Thank you.
Thank you.
Thanks. Bye.